So today, as promised, we are talking about power series representation of functions. That is to say, we already talked about the power series just as some sort of object to find out where this makes sense. In other words, where does it converge? What's the radius and interval of convergence? So we know how to do that. But what we can say about this, what we didn't do, is say that, all right, on its radius of convergence, let's say this has radius of convergence r. Okay, we'll just call it r. We can call this a function, because any value of x is going to converge to some number, right? All right, so that's not a big deal. That's all we're doing. And we already know one. It's our friend, the geometric series. So I'm going to show you, right, we're used to the geometric series. We know what that sums up to. We learned it this way. AR to the n minus 1 is A over 1 minus R. Now, they often like these to go from 0, not have this n minus 1 here. I don't know why they started that way, but okay. So I'm just going to reindex this, right? So I'm just going to, instead of starting from n equals 1 and having a power of n minus 1, I'm going to start from n equals 0 and have the power n. Now, we talked about this way back in our actual classroom when we first did this. I said something, I sometimes start from n equals 0, but so now we're going to do that. So then that's fine. And we know that this converges for x with a value of r less than 1. Okay, so all I'm going to do is kind of switch this around a minute. I'm going to let a equal 1 and r equal x. I'm going to write it the other way around. So then I have 1 over 1 minus x. And that is equal to this series, which I know looks like this. This is the series. And this is true for every x between negative 1 and 1. Okay? Now, I'm going to say, so we're going to play around with this for a little while. This is a great example. Shows us what we can do with these series. My notes are all out of order. There we go. But it's only one example. That just happens to be one we already have in our pocket. So that's what we're going to use it in section, whatever this is, 11.9. But in the next section, when we learn Taylor and Maclaurin series, we'll learn how to take any function, not just some special ones of this kind of forms, and do this thing. Okay, so that's basically most of this week is what we're going to be talking about. But first of all, before we go on and talk about sort of more general forms, let's say we can actually do quite a bit just with this example, right? Let's say I want to do 1 over 1 plus x squared. Well, all I want to do is take, this is actually like 1 over 1 minus negative x squared, right? I'm going to write it there explicitly so you can see what I'm going to do then is I'm just going to take this, what is in parentheses, this negative x squared, I'm going to shove it in there. And now, okay, and I can clean this up a little bit. Minus 1 to the n, x to the 2n. Okay? There's another part of this, which is, of course, this. So the radius of convergence. I'm changing x to negative x squared. So I have to change this x to negative x squared. But the absolute values, right? So I can pull that out. The absolute values kill the negative. The square can go out, but I can take square root of both sides. And that's just the square root is just 1. Okay? So don't forget, whenever you use a power series, it has a radius of convergence. Okay? For some of them, it will be infinity, and then you don't have to do anything. But for any time it's some particular interval, especially for the geometric series, we have this, then you can do this. All right? So that's one example. Let me do a couple more of the same sort. Start a little bit further over here. This one, for example. Okay, so this doesn't entirely look like that. What I want to do, though, is make it look like that. So first thing I'm going to do is I'm going to pull the x out. And then I have this. I think that's not that bad. That looks very similar. Now what I'm going to do is I'm going to put, again, like this would be negative 2x squared, right? Because it's 1 minus 2x squared. I'm going to put negative 2x squared into that. Okay. Whoops. So I've got minus 1 to the n, 2 to the n, x to the 2n, right? Now, I'm going to be a little bit careful. I want to make sure that all my x's go together, so I want to pull this x guy in here. So my final answer for the terms of the series, I want to make sure all my x's are pulled together. Okay? And now I still have to do the radius of convergence. So the radius of convergence here, I have to do a little bit more because I have a 2, right? So if I stick in negative 2x squared in here, right? That's going to be 2 absolute value of x squared is less than 1. Absolute value of x squared is less than 1/2. Or absolute value of x is less than 1 over root 2. Okay, so this is a smaller radius of convergence in this case. And that's part of my answer. So you have to make sure when you're doing these that you keep that part in your answer. Okay? Now, it might be easier if I wrote this up a little bit more out of the way, so we had a little bit more space. Because my next example, I might need a little more space. Four over 9 minus 2x. All right. So here It's like that, but it's not like that, right? Because I need 1. So first of all, 4 doesn't matter. Like the x in the previous example, I'm going to pull that guy out here. Right? But this guy has to be 1. It's not. It's 9. So basically, I have to pull out the 9, right, as well. So in other words, that's like multiplying this whole thing. I can multiply by 1, right? You can think about it as multiplying this whole thing by 9 over 9, pulling that 1. Or you can just think about it as pulling the 9 out. I don't really care how you think that. But 9 is at the bottom. And then you're going to get 1 over 1 minus 2x over 9. Okay? This is something you will actually see more of doing stuff like this with these. It actually is quite important as you study more mathematics. So it seems sort of weird, like why I would want to do that. But believe me, it's easier than trying to do the Taylor series. Okay, so now my x term is just 2x over 9, right? So it would be 2x over 9 to the n here. So, yeah. So really, they kind of like to put everything back in. So, this would be 4 is 2 squared. So this would be 2 to the n plus 2, x to the n, 9 to the n plus 1, if you make them all together. Right? And so remember I put in 2 ninths x for the x, so I have to put it in here, right? This case is not squared in this particular example. So I don't even take the square root, but if I look at my radius of convergence, let's do right over here, I have 2x over 9 less than 1, or x is less than 9 halves, right? Because I can pull out the 2 and the 9. That. So that is how those are. So you can multiply by, like if it was 4x cubed here, then I would just keep the x cubed out and multiply through, whatever, you know, whatever it is. The idea is that you want to build this from our known series. So whatever you have, you got to kind of massage it until it's of this form. And then you substitute whatever this mess is into there, and you're good to go. So that's one thing we can do. Now it's not all going to be in that form. There is something else we can do, but I'll save that for the next video.